component doesn't know anything. It responds. If it's a temperature control, it responds to what?
Temperature.
It is manufactured to respond to what? So therefore, it is when you spoke of bimetal, it means that it is assembled or made of two dissimilar metals that when they heat up, you can form a component to make that component bend with the temperature to close or extract to open. And we usually have a bimetal that is gonna function, say it has a diaphragm that bends inside, and there's usually a button. So when it flexes, it touches a button. If we wanted to close something, if it is a bimetal switch that is also in what circuit? You're talking about heating, so what circuit would it be in? You may not know yet. It's in a series circuit. The series circuit is gonna be control voltage. The control voltage is what? What's the voltage?
24.
24 volts usually carries what circuit? It can be two. Safety.
Oh, safety switches.
Bimetal, thermal, safety from heat. Overheating.
Remember the cap, the key I brought in. I don't know what
That's the key.
hands for the
Machine for the service port.
Yeah.
It should be that screwdriver in the office in that first top drawer in the back office. I left it right there.
Okay. Is it unlocked?
I think it is, unless Duncan's guy locked it.
Okay. All right. Well, Paul is looking for it. I know.
Oh.
Yeah.
There you go. You know we ain't bought none of that. When you first see them, but they tell us what an item is, where an item is located, and what the particular furnace manufacturer calls it or labels it in a legend, which is on the other drawing. A legend says this what this shape means, but that's only part of it. So what we're doing is saying we know what the shape is, that's just the symbol. The symbol represents what? That's it. It represents a component. So you take the symbol, okay, it represents a bimetal switch. Now I have to know what a bimetal switch looks like. It has numbers. Everything we use has numbers on it. The numbers mean something. The temperature that it opens and closes. This is a bimetal switch. Somebody heated it up with a cigarette lighter so that they could put their meter there to see if it opened when the temperature exceeded the rating on here. And it cools off, it closes. So this is a bimetal switch, limit switch. Bimetal limit. So if it's bimetal limit, what does limit mean? Limit, just think of what limit means.
It only goes, don't go no further.
There's a point where that's it. Can't go any further. So it limits, in this case with a furnace, it limits how high heat will be able to be allowed in that furnace without having air blow across it. Because if no air blows across it, across the heat exchanger, nothing else, no air is going to be delivered through these supply ducts, and it's going to get hotter. If it gets hotter, we could have an issue. We could have a fire, we could have something tragic occur. So we put limits. The limits are gonna be in what circuit voltage? 24 volts, which is called safety. But also, there are two switches do two things. And what is that again?
On and off.
Switches open and close for two purposes. And what are the purposes?
Activate.
You always know the one purpose, which is safety.
Activate and deactivate heat and pressure.
It can. That is what it does, and that's good.
Voltary load.
It can,
Turn something on, turn something
it can close, when a switch closes, it continues line voltage to a load. The load is actually carried by the component that has a what in it. Because in order to have, if it turns, if it opens and closes, if it has action, it's gonna have a coil. So we know if you are a load, whether you're electric strip heat or whether you're a gas valve that has a little tiny coil in it, a relay or a contactor, you are a load. And if I'm a load, I need positive and negative for magnetism, for movement. And I also can put my meter on and test what? Voltage, but what else?
Resistance.
Current, resistance.
Resistance on current.
If I have voltage on it, I'm not testing resistance. Amps.
Oh.
Because if I'm functioning, I'll have amps. If I'm not functioning, because the motor is locked up, I will draw higher amps. And amps is what?
Current.
Amps and current is the same thing. It is. I don't know why they do it that way, but it'll draw amps. And every motor has a rating on it. And the rating will say single phase, 60 hertz, half horse, 208, 230. And sometimes it will tell us, it'll tell us the amperage. It has 1050, it does RPMs and 4.1 amp. So it should be that, no more than 6%. It could be more than 6% amps if the fuses, if the filter's dirty or the motor is dirty in these vents because they haven't changed the filter, it will clog it up and that motor start getting hot because these are cooling vents that help cool that motor off. And so if the amps go high, higher than the rated, the motor usually tells us what is LRA.
Low resistance,
Locked.
low
Low torque. Amps. Which is usually 5 times more than the amp draw. And if you see that on a 4.1 and you read it and it's saying 20, that motor is history.
So you just know it's a bad motor off the top there. You don't have to.
Motors are not bad. It's a failing motor.
Failing motor.
It fails.
Electrically or mechanically?
It could fail because we can often have components that can fail more than one way. We can fail electrically, which you usually know because you sometimes can just see burnt windings or shorted windings. Sometimes there's nothing wrong with the windings, however, the shaft will lock. And if the shaft locks, energy and voltages are applied, you're gonna draw a higher amperage if there's no rotation. But many times there's still something wrong internally with the motor's windings. Ask questions.
Is it anything to do to unlock it, or is just it's
Done
failed
deal.
all the way?
Done deal.
Okay.
Replace it.
I
Done
had a
deal.
question. I don't know if I'm asking it right. Back with the bimetal switch, because you kind of went on.
Go
You
ahead.
were saying something about the air blowing across the.
The heat exchange.
Okay, where did the air? You talking about the air from outside? What air?
No, that's a
From the
good
vents.
question.
Right?
Here is a heat exchanger. I'm not picking everything up. it right here, you can, but I'm not gonna pick it up.
So Greg, what is it?
If you wanna put it on this table, you can put it on this table right here. Right there. That's the heat exchanger. Heat exchanger, that's one type. Inside a gas furnace, this is a plate heat exchanger, and this is where the heat, like an iron that you iron clothes with, the heat exchanger must be sealed. Can't have any holes in it, any cracks. This is where the stack goes up out the chimney. This is a 80% because I can tell by the size. This is what? Same as this, that's on an 80 and a 90% furnace. It is an inducer fan motor. Inducer fan motor is hooked up here, and what it does, this connects, this is from a 90, this is an 80, and it goes up and takes all the toxic chemicals outside. This motor is called induced fan because it spins and pulls the fumes and creates a positive pressure on the heat exchanger. This is the heat exchanger where the burners are going to be heating up. The burners are going to be heating up.
Oh, that's where it goes into.
The burners are going to be heated up, aligned right there, but not that close. They'll be out here. And the burners are sticking here, and that's what's heating it up with the fire. Now, the other part is that there's some other parts that'll be here, but this has a lot of heat in it. Constant heat. Each burner represents a certain BTU of heat. Maybe 25, that may be a 75,000 BTU furnace that can deliver that much heat. It has 3. When the heat goes there, there's also different types of limits. These are around, there's some square ones like a deck of cards that will go over here. But the bimetal would be on the inside as far as how it's made on that particular component, which we will show you. And so there is only a certain amount of heat that can be allowed in that heat exchanger before it can get to the hazardous zone. It's designed that way. All furnaces are. It's really remarkable that you could take a little bimetal switch to control by temperature how hot we allow this furnace to come on. That is a safety to say, hey, sometimes they will put those bimetals not just in here, but they'll put them on the side of the heat exchanger somewhere here. They don't want no heat to come out here. Sometime it'll be one sitting right up here, and it has a button on it, and that's called a rollout switch. The difference between a rollout switch, it is bimetal, but it has a button for manual reset. For manual reset, because it's a rollout. What would roll out of this heat exchanger? Fire. Is that good?
No.
Oh no. So if that rolls out, it has to be manually reset by a technician. I'm not going anywhere with a rollout that needs reset and click it. I already told you the story, and look down there. If the rollout opened, then fire came out. That's the knowledge we know by components.
Right.
Oh, okay.
I'm not gonna set no rollout and see what the flame look like, cause it rolled out. I don't know if it rolled out that much. It doesn't take much temperature. That's the safety. If fire goes, that's it. It doesn't have to make a dragon to cut it off. That's it. It's off. That's the roll. That would be the rollout. And you could have them in a furnace. Yes.
Isn't there a safety switch for like water? Like, you know, if it overflows with water, it stops it.
What water?
When it's
See, I'm gonna ask you. I'm gonna always ask you something.
the furnace.
Yeah.
You know, like at the plate when it like has too much water because it like the line is frozen or something like that. Isn't there like a safety switch that stops it.
It is a safety flow switch, and if
Isn't
it's
that-
a safety flow switch, what circuit is it in?
24 volts.
24 volts. And if it's a safety flow switch and you said water flows up, what is it protecting for?
Shop,
For what?
ready for shop?
For shock?
Yeah.
Now we hope it's not shock. What? You brought it up, what?
Overflowing.
What's overflowing?
The
water.
The water, so there's
From
gonna-
what? Where water come from?
Constant,
The
Evaporator.
coil.
The evaporator coil? Yes. Why would
Yes.
water be on the evaporator coil?
It's coming from the evaporator.
Why? Why?
Because it's sweating and
Wind condensation?
Why is it sweating and condensate? Where did that condensate come from?
The heat that is taking up.
Yes.
The refrigerant?
It's not pulling it out of the refrigerant, but you might have been on the right track. Where does the moisture come from?
Heat that is taking up.
Humidity. Where does the humidity come from? It ain't coming from outside, but it
Inside
could
of
on
the
a
attic.
commercial unit. But what?
The inside of
This
attic.
room. This room. Because it has a return. And the return is where the filter is. It pulls all the airflow in this room through the evaporator, which is what? What is an evaporator? Hot or cold?
Hot.
Evaporator's hot.
No, it's cold.
And we use an evaporator
For the
during what
AC.
time of the year?
For the AC?
all year.
For AC, on air conditioning. The heat pump might be a different story, but on an air conditioner, it's in the summer because when we turn the system on from the thermostat, and if we're turning the thermostat, if we are energizing the thermostat for cooling, what three color wires are we energizing when we put it on cooling and lower the temperature inside below room temperature? What three wires?
Why for, yellow?
In the fan,
Cool.
G.
Yep, because R and Y are gonna do what?
Power and
Power.
cool.
What is it gonna power up?
The
motor.
fan,
What fan?
the compressor.
Indoor.
Indoor motor fan.
And the, oh.
The
What
condenser.
we talking about again? The
Okay,
evaporator.
condenser.
The cooler.
So,
Yeah, the one outside.
so if the condenser is outside with the compressor, and we already know that what is the voltage to the outdoor unit? What is it?
240.
And so this is coming straight off of L1 and L2, and when we close this, it's not a contactor, it's a what? Service disconnect. So it's disconnecting power to that unit if you wanna work on it. Or you're gonna get torn off the frame with 240, you're gonna touch that if you want to. So you always take the switch and put it to the off position. And it shuts everything off of T1 and T2. Is L1 and L2 still hot?
Yep.
Oh, yes. L1 and L2 is still hot, or L2 and L1 is still carrying line voltage. What would we have to do to get rid of the line voltage and to open that switch?
You gotta cut it off at the main.
The breaker. So this goes back to the breaker. And you can call it main breaker. And it's gonna have several breakers, isn't it? And it'll have a main at the top. It might be, I don't know, 100 to 400 amp service. Amp service. Why we call it amp service? Why is a disconnect based on amps? You have outlets in every room, you have stoves, you have dryers, it might be electric, it might be gas, you have toasters, you have television, you got 6 televisions, you have refrigerator, all of these appliances. And especially if you in one of these modern construction type of approaches, you're gonna have electric water heater, electric stove, and what amperage does that take for a stove? With an oven, and here, and a microwave, and sometimes 2 ovens, don't they? Some of the more expensive ones, not like mine, has a little oven at the top, an oven at the bottom. What's the voltage on that?
240.
240. And if it has 10 amps or 15 amps, but it's not gonna be that small. It's gonna be 40, 50, 60 amps. Okay, so I'm explaining to you what that means, that a 400 amp service. Okay, 400 minus 50 for the dryer, electric, 50 for the stove, 50 for the AC, and then all the other little outlets that you're running in your house. Some are 5, some are 10, not 5, but 10, 15, 20, most of them, 15, 20. So you add these up, and we already at what? 150. So you can look at it and say you took away 100, that's 3, take away 50, that's 250. So we only have 250 amps left for the whole house. So that's why you can't say, oh, there's some empty circuit breakers here, I'll just use one of these. Well, what kind of amperage are you looking for? It might not be that much left. You might have to have another service pulled off in order to continue that service. And a lot of houses are still 100, 150, 200 amps. I don't know what mine is, I think it's 300.
And then, you said the whole house, not
Whole
one.
house. That's the
Okay.
whole house. When you look at the top of that breaker, whatever that number says, that's the amps for the whole house, maximum. So, you know, when they install these electricians, they look at the circuits all on the wall, lights, outlets should be different than ceiling, unless the ceiling fan has another switch, a 3-way switch that operates that as well. It might go like this. Electric fireplaces now. Do you seen them? They look like it's burning real wood. You seen them? They look good, don't you?
How much that?
I ran mine twice. Thought about the electric bill, turn it off. And they give you all of this. I guess you could be sitting on the couch and go tick, tick, like James Bond. This fire comes up. You can make it brighter and brighter. You can make it duller. You can make it wave more. It looked real though, for real. I said off. Probably cost me $50 tonight going off, but would work better. But
Then, I guess it's called a GFCI.
yep,
Where, so is that a bimetal behind that flicks it off?
it works much like it's thermal, because what happens when amperage rises?
Well, the fuse
All
is-
circuit breaker type of devices work that way. What is the amperage of that breaker? What's the amperage of that breaker? What's the amperage of it, you know?
It don't say on the side, you won't know.
It says it right on that little switch, that's where you see it.
The switch at the top,
Yep,
48.
it's 40 amps. That's a 40 amp breaker. What's that one? 20 amp breaker, they look kinda just alike, don't they? But it's a 20 amp breaker, it's half that size. If you put that on a 40 amp appliance, it's not gonna work. It's not gonna work, it's gonna trip. Because amperage represents, to get to your question of thermal, heat. High amperage, high temperature. If we start pulling amperage to near rating, which 40 and 20, the amperage is gonna be right there. If it gets higher, it's a thermal switch. What's gonna occur with the breaker or the thermal switch?
It's not-
Open.
Open.
And you could say trip on a breaker.
Hold on, can you run that back? You said if you put the wrong one, it's gonna open.
If I have a 20 amp going back to here, we said that's 240, you got a compressor, you got a condenser fan, motor, and so we know that there's probably gonna be 40 to 50, depending on the size of that unit, to 60 5-ton amps. Now you go ahead and take this and say, well, I have one that'll fit, and put a 20 amp in there. What's gonna happen?
It gonna blow, trip, right?
It's gonna trip, because the machine says 40 amps is the maximum, but it might take 33 to operate. You know, always say, we got a little leverage in there, 6% leverage. So if you have a 20, when that compressor starts up, it pulls. When a compressor or a motor starts up, it pulls 80% of lock rotary amps. So even if that motor takes 19 amps for a fraction of a second, faster than this, when that motor starts up, it's gonna pull 80% of lock rotor. Lock rotor could be 45 amps. That could be lock rotor for a split second. And that's why we use capacitors to get that motor over that hump. Can you go to the definition of that lock rotor again? Lock rotor is, as electrical, lock rotor is when we exceed the nameplate data of that motor, which would be RA, running amps. Guess I should have said that. How many above? That's what I'm trying to see. How much above? Okay, so
It's called running amps.
running amps would be that 19 amps, okay? Lock rotor would be probably anything over 20 amps. It's starting to pull on the safety. It's that, when you see a breaker or a component that's marked for running amps, that's all it needs to be balanced and to continuously run. That's why we amp out. You have an amp meter and you say, hey, that's amps. But you look at that rating as a service person and say, hey, that thing at 36 amps. And you might say, I'm gonna keep going off. I wonder why. That's why we break down components in what they are. Oh, that's a motor. How does it work? How do we validate how it works? Amperage, voltage, lock rotor, running rotor, whatever it takes, RPMs for a motor, it tells you rotations per minute. Indoor fan is gonna have a different RPM rotation than an outdoor fan. We're moving way more air outside. Probably 5 times more air outside across this unit because there's heat out here. And if we don't get rid of the heat from that unit, we can't cool. Because heat goes from what? A what place to a what place? You're gonna hear this the rest of your time here. From a warm to a cooler place. But here's what I need you to understand, because this is one of those things that's like you accept the science and don't try to become a weather person. Oh, well, this is a high pressure. We're not doing it like that. So when we say from a warmer to a cooler place, when this refrigerant absorbs the heat from this room and the moisture from this room, when it makes its way from the evaporator, it may be 124 degrees Fahrenheit. It could be. And you say, well, warmer to a cooler, it's 98 degrees outside. What's ambient?
Outside.
Outside, Tim. Surrounding air too. So you can have, you are right, you can have ambient outside, or you can have ambient inside, surrounding temperature, whatever is surrounding. Okay, so if it's 99 degrees Fahrenheit ambient, is 99 degrees cooler than 124 degrees?
Yes.
So you need to know that, because you could say, well, how could it remove heat? It's almost 100 degrees out here. Well, we bringing to it in this coil 124. So it still goes from a warmer to a cooler. That's why I don't like to say a warmer, hotter to a colder. It's just a difference of temperature, and the greater the temperature difference, the cooler it becomes. The cooler it becomes. So the air from ambient goes in the sides of the vents on an air conditioner, and it dissipates from the top. So it's bringing this ambient that's cooler, sucking through, going through these coils, all of these coils on an outdoor unit, you'll learn more about, and then it cools those coils to below the temperature that it came. So when it returns back to the compressor, it'll return to the compressor and go through the metering device, which is TXV in this case, or piston, or cap tube, which is a restrictor. You'll learn about that as well. And it'll come back as a liquid. And as it is restricted in the metering device, it will pressurize it and make it colder. So by the time we go as a 95% to a 25% liquid vapor droplet mixture to the evaporator, time it goes into the refrigerant goes into the evaporator, heat goes from what?
Warmer to cooler.
What's cooler now? The evaporator. The evaporator's cool. So all that heat sucking up in here is gonna keep going through that 40 degrees or 45 degrees evaporator until the temperature in coming out the ducts at the thermostat on the wall, the thermostat says, hey, you set it at 75 and I'm at 75. So what happens? What does it do? It cycles off. We talking air conditioning talk. You're gonna learn that too. It cycles off. So I talk to you as though I'm interviewing you, so you'll be very prepared and mature how you talk, because interviewers listen to what you say. Like, I'm interviewing somebody this Thursday. I'm gonna listen to how they speak this, and I can tell how smart they are. You can't BS me. You don't have to say it like me, but I use words like open and close, energize and de-energize. That sounds better than make come on, make go off. Well, it's a thermal switch, not a limit switch, it's a thermal switch, because the thermal switch operates on the principle of heat and temperature. Or it could be a thermal switch that could be a thermal switch on the cooling side that opens and closes either on pressure, low temperature, or high pressure, high temperature. So it's letting me know as a prospective worker that you understand the principles of operation. You don't have to be a genius, but I do want you to understand all this we're gonna be talking about, because all of this affects how you address a service call. If I don't know how to determine the amperage on the circuit breaker, how do I know somebody jackleg didn't come in there and and the only problem, well, the unit keeps turning on and off. It'll run about 3 minutes or less and turn off. I'm gonna go look at the breaker. They went to Home Depot or Lowe's. It looked the same. It'll fit in there. It lines up the same, but it's too small. There's nothing wrong with the machine. It's the breaker. So you have to get used to knowing the components, what do I look at first? The first thing you look at, I know you know this, is what? Oh, thermostat. What?
Is it on both?
Voltage. Voltage outside, if I'm on air condition, and I wanna see if I have 240 outside where? Where?
Cut off breaker. Cut off switch.
At the disconnect.
It gets disconnected.
See, we're gonna be talking, we're gonna say disconnect. But it could be a circuit breaker in the disconnect. But it's at, or you could test it somewhere else on that unit, where? But if you test it at L1 and L2 at the disconnect, it tells us, it doesn't tell us anything, Harrison. It lets us know that I do have 240 volts from the breaker box. Some people call it a load center because all the loads are connected to a particular breaker switch. So if I have it at L1 and L2 on the disconnect, I have it at the unit. How could then I get it to the compressor and the fan? How does it get to the compressor and fan? How?
Wire.
Wires?
You said, how does it get to the compressor and the fan?
How does the line voltage get to the fan and the compressor?
Through the condenser.
We talked about it, but listen to me. We're talking and speaking about components, because that's what all of this servicing is about. Components. How does it get there? How?
They go through the transformer first.
Well,
Go through the switch.
I could kinda accept that answer, but you gotta tell me what that means, going to the transformer. What does that mean? Cause transformer has what kind of voltage?
120.
What?
That's 242, right?
Transformer doesn't have, well, let me tell you this way, cause it depends on how you're doing in lab. If you have a multi-tap transformer, and that's what if you're talking about that on the primary side, it could be 115, 208, 230. It could be several different voltages that same transformer can be wired for, whether it's black, white, red, orange. It could be wired on that side so you don't have to carry all those different transformers. We used to have to carry all them different kind of transformers. A multi-tap means, hey buddy, you can wire this up to 5 different ways and it'll work. You only need one. As long as the VA on it is correct. What is VA? There you go. I don't have to write that down. Voltage amps. Okay, so if you had a said transformer, and I say, cause I'm interviewing, remember, I do everybody like this on an interview. I don't say you're wrong. I say explain that, cause everybody don't think like me. None of us think the same. And if you had told me, well, if I have 24 volts in my control system, it will, when energized through, you told me red, what, for AC?
Yellow.
Yellow, and what else? Green for the indoor fan. Well, the 24 volts that I'm speaking of, Mr. Harris, is the 24 volts that goes to the contactor. I could have accepted that. Because when I have to call for cooling before I get cooling. And I already tested that I have 240 volts at the contactor itself at L1 and L2. But I don't get it to T1 and T2 until what occurs?
The contactor.
The contactor has to close. So if you had said low voltage and said, if I don't have 24 volts to close the contactor, nothing runs, even though I have line voltage of 240 at L1 and L2, it does not get applied to a load. It does not get applied to a fan load or compressor load until this coil is energized, closes, and T1 and T2 become part of the circuit, because all a contactor is a electric switch. Power's there. You close that, it's on the bottom. You stick your hand on it, you're gonna get both ways. Bop, bop. is closed. So if it doesn't close, what would you check? Teaching you how to troubleshoot so you'll understand wiring diagrams.
The 20.
Transformer.
What?
24 volt.
24 volts. So if I take my meter and go here, and the system is energized, which means it's calling, right? And I have 24 volts there,
Bad contact.
then the contactor has failed. That's simple. It can fail electrically or it can fail mechanically. Sometimes the stuff inside, these gears, they fall off. What if this transformer,
Where would they be located? I'm sorry.
huh?
Where would they be located at?
It would be located right here in the condenser.
Inside the condenser?
So, right here, so the power from here, the voltage from the disconnect goes to L1 and L2. It comes out of L1 and L2. How many wires do you have on a compressor? You don't know that yet? How many
Wires?
wires to connect?
4.
You don't know that yet?
4. No idea. 6.
One has an inlet and an outlet. What about the wires?
How many?
3.
Start,
About,
run, and common. 3 wires.
okay.
And you're gonna learn this because this is how it is on the drawing. And so you have L1 and L2 coming off here with 240, and then when you close to T1 and T2, 240 comes this way. So if I have my contactor with L1 and L2, then,
Question,
what question?
does that go through the capacitor first?
It actually does. I was coming right over here. There are 2 different types of capacitors. What is the difference between these 2 types?
One starts.
Give me some answers, Footman.
One starts. One.
What's the difference? Just look at it, at least tell me that difference. That's true. One is 2, one is 3.
What's that dual? What's the dual?
This is a dual,
And this is a,
and that's single. Mostly found on indoor furnace fan motors. Mostly. You have, what color are the wires that normally come to this indoor fan motor?
Green?
White and
Yellow, red? No.
Black, white, and yellow.
That's different. What?
White and black.
What?
White and black.
Black, white, yellow.
green,
Not to this. I normally see them another color.
Black, white, red.
Oh, it'll be 2 brown wires.
2 brown wires?
One of them will have a stripe, and it'll come out the back of the motor. Not this motor, because this motor is not a good example, because that motor is an electronic ECM motor, the modern type motors that changes AC to DC. We ain't talking about that yet, but we're gonna get there in this book, in this class. What an ECM motor is, electronic communicable motor. It changes AC to DC through a process called rectification, which can make DC function like it's 3-phase. We're gonna talk about that, because you haven't got to 3-phase different than single phase, have you? We're gonna get there. And then this is gonna make a little bit more sense, but right now we're staying on the basics of how voltage and amperage and components are assembled, thank you, are assembled to make one machine work outside and another machine work inside. They do have some similar components, but not really. Because how can we have a thermostat inside, generate a closed switch and an open switch outside of a condensing unit? So that means the wires go from in to out, only on low voltage. Only on low voltage. Because outside has a disconnect, but for its own operation, and a furnace inside has a heat exchanger, a blower with a motor, and it has that coil on top of it, of course, the evaporator coil, and then it has ductwork on top that blows it to a room. So the furnace will have, you'll learn, what kind of board? IFC board. It's a circuit board, but remember, we're gonna be techs, high techs, master techs, dragons. We used to have dragons. Everybody wanted to be a dragon in this program, but you couldn't just be a dragon. You had to be the top of the class to be a dragon. I mean, I could sit in that chair, you're talking just like I do. I love it. I'll be smiling and laughing. I'll be like, that's what I'm talking about. They be talking dragon talk. And we even had t-shirts. And they'd wear them in the school. I'm a dragon. I'm a dragon. I'm getting ready to get employed. You might get one, but they're gonna come looking for me because I'm a dragon. Meaning that, and I may start it up because that was my best friend that did that. We worked together for years, writing books and material for HVAC. I still haven't got over his death. It
Be
was
like
bad.
that.
I have a question.
Yeah.
How is that box grounded with relation to the components on the inside?
How does what?
How is that box grounded?
What box?
The comment on the compressor gets grounded
All of
somewhere?
the whole box. Should it be
This
grounded?
is not grounded. Only electrical items are grounded.
I'm talking about the unit, the box you saw where everything fits into. I don't see one.
Case ground. It's
Oh.
called case, C-A-C-E, ground. And that's a good question, because case ground simply means that I take this wire and where it's in the front, like this one, that's case ground. They just took the ground to their motor and screwed it into the case. That's a case ground. That's a case ground. Case ground goes all the way back to the breaker, which has really it has a bar over here that is ground, and it could have also, that's the major ground that's going into the ground itself 15 feet or more. That's earth ground. Earth ground grounds the whole box. You'll see about a meter, a rod in the ground. That's earth ground. So that would be earth ground, and it has a rod all the way down, and all the other grounds are connected to the earth ground. So if something happens, the power force goes right to earth instead of to us. We don't become part of the circuit. And so every other ground goes to ground, and ground goes to earth ground. So case ground goes to ground, and ground goes down to earth ground, and then it's also a neutral. Sometimes you open it up, it can get confusing because it looks like neutral's on the ground, but it's neutral. Neutral is not common. I didn't get that at first when I started this when I was a young lad. I didn't understand because I didn't ask the question, what's the difference between common and neutral? And I know people don't know it. That's why they be burning up all that stuff in the electrical. Because I run a boot camp in my electrical lab. My students be the bomb. Neutral is the opposition. So if I want 120 on a motor, I have a neutral represented N, and then I have a voltage. Common sounds like the same thing when you first start. Doesn't it sound like the same thing?
Yes.
Yeah,
Mhm.
it
But
does.
it's really not. And nobody ever told me that. And I was like, but I would look at drawings and say, oh, it makes sense. It was confusing me. It doesn't make sense to me. Because someone said that it's 3 probes on here, and someone said that it saves money. All this stuff about saving money, and because we used to have 1 2-prong for the compressor, 1 2-prong capacitor for the motor. And somebody said, bump that, we're gonna make it together. It's called a dual. Here's where I'm gonna explain what common is. So one terminal either say, oh, it says it. This one says herm. What is that? Hermetic. What is hermetic? They're referring to a hermetic compressor. Small compressors mostly, but they don't have to be. that are sealed. You can't fix them. Your refrigerator has a hermetic compressor. Those air conditioners in that lab have a hermetic compressor. You can't fix anything. And throw them away. They're no good. The other one says fan. What fan are they talking about?
Condenser fan?
You probably don't know. What fan?
Condenser fan?
Huh?
Condenser fan?
The condenser fan. Doesn't this make sense though? I could take this component, because that's where it is, and I could take fan, put it on the one from fan. I could take Herm from the compressor and put it on here. And I have a terminal left over. Look at the top. You know what terminal that is? C is common. It's not a neutral. If you wire it that way, papoom! You're gonna get a big spark in your face. You're gonna be scared to hook another wire up for 2 days. So, common means in this case, which nobody told me, so I'm telling you. Common means on that terminal, it is, sometimes they just say H, F, and C. The compressor, Herm. The fan, fan. C goes to L1. And they share L1. That's what makes it common, because they have a common share for their voltage. That's what makes it common.
So they go in a path.
This is Harrison. Please remove your car. That's it. That's it. Y'all, is it time for y'all to have a break?
Yeah.
Yeah.
No, y'all got 10 minutes. You got 10 minutes.
Mr. Harrison,
Huh?
I think, explain it again about them sharing the common voltage.
Okay.
Common go to line one, and that's why it's common, because it's sharing the electrical.
Common is common in this case. It is not a neutral. And I know why I know why it's a rub. Because when you're taught basic electric, 90% of the time it's talking about L1 to neutral, which equals 120 volts. And your mind is set for 120 volts. So neutral is common. But it's not. Common is a common terminal we share. In this case, the common terminal we share is L1. So the compressor will have a wire on L1, the motor will have a wire on L1. Then the other one goes back to the motor, the other one goes back to the compressor. Because the compressor has a start, run, and that common. And one side of the run goes to T2, one side goes to L1, and the other one goes to common. So when you don't put it on T1, the other ones go to T2 because you don't want them to energize until the contactor is closed. Nobody ever explained that to me. That's why I write these little books about servicing. Nobody ever said that to me. It didn't make no sense. It just didn't make sense. And students, when they start off, they struggle with that because you spend too much time on 120 volts. Now 120 volts goes to what component compared to 220 and 240 rather going, you told me, where does 240 go? Outside. Where does 120 go on a gas furnace? Inside. The supply, I didn't finish. The service disconnect on a furnace comes here as 120 volts, and most of the time it only has the need for 15 amp service. That's it for a furnace, 15 amps for a gas furnace, that's it.
So it would be a transformer somewhere to get the 120. How you get the 120?
The 120 doesn't come from a transformer. The 120 from this furnace, where we're bringing it in right here, comes from the breaker box. That's why we said it's a breaker box or load center, which means it carries the load for each device with a coil.
So whoever
With the
put the
coil.
breaker box in gotta set it up for that, or we gotta do that?
We don't, some people do. I do sometimes. I done got to the point, I asked my electrician, I need to run from here, run from there, this and that. He's an electrician. He does it so neat. It looks so good. It makes me look good on my job. I say, how much you gonna charge me for it? He'll tell me, you ain't getting no more. Better look at it good. Ain't no more. You miscall the money, it's there because it ain't coming out of my pocket. You know, like asking, you know, I know how to do it like you know how to do it. I said, I'm telling you, if you need $1.25 more, that's on you. You should have called it right. And if you say something really ridiculous, I'm gonna say, hold on to that, Marvin. I'm getting ready to get Terry to give me a price too. They want two prices. Marvin might tell me I want 2,200. Terry might say 19. I'll say, Terry, you priced yourself out on this one. I'll catch you next time, buddy. You say, well, what Terry doing it for? 19. You just tell him, I'm telling you nothing. I'm telling you, I'm getting ready to call him now. I don't have to play games with you. I need this done. I'll do it for $17.50. But can you do it Wednesday? I can get it Friday. Terry doing this Wednesday morning. It's gonna be done by noon. Cause I'm cranking this up at 4 o'clock this afternoon and going like this. Oh, I ain't waiting for you. You all right, cause you got so much work you can't get here till Saturday. So you doing good, you don't need this money. That's how it goes. I ain't waiting for nobody. If I gotta wait for you, you ain't ready to work for me. Cause I'm trying to get that money and keep on moving. And you gotta look professional. I look like Steve Urkel, and I do business like Truist Bank. And if I tell you it's gonna be done, it better be done. That's the worst thing we can do, is to tell somebody it's gonna be done and it's not. So if Terry said he'd do it when Harry asked, and I'm sorry about it, man, I blew my engine. That's all right. Hey, Marvin, I'm gonna give you another chance. I'll give you 19 today, instead of that 17 you asked for, if you can do it today. I got your answer. And then, hey, Terry out the picture. I ain't mad at you, but I promised my customer that I would do it. Cause you know what they'll say?
You don't do what you say you're gonna do.
That man, he good enough, but ooh, is he a liar? And you are. You a liar. Don't say what you can't do. Don't promise what you don't have in your hand. Oh, I can put it in Wednesday. Now I call it the air conditioning warehouse. Harrison, we get them in next Monday. We get 100 of them in next Monday. I done promised them. So now you get everything together before you say that. Everything together. And I do it. So my biggest compliment I get is, to me, it's a compliment. Mr. Harrison, good girl, I'm gonna tell you, he ain't cheap. But it's gonna be working right, and it looks good. All my work looks good, man. I don't have no raggedy wires running, no funky tape, mastic all over there. I paint that mastic on there and wipe it off to a straight edge. I polish the furnace off with cleaner when I'm finished. My stuff look good. I clean up everything around it, my dry vac inside, outside. I got a little kid rake, and I rake whatever. I don't leave no cut wires from thermostat, none of that, no wire nuts. That's why I be raising hell in that lab.
Do you always
Because
use
it's
connectors?
training, huh?
Do you always use connectors, like when you're doing
For low voltage?
When you in the lab, you know what I'm talking about?
The wires are already connected to the machine. The only thing we do is bring in L1, L2, and ground, and low voltage. Everything else is attached. When you hook up to L1 and L2, and you hook your thermostat in, and you hook up the 2-wire, because it's called 2-wire, that goes outside. You do know that or not?
No.
It's called 2-wire. You know why it's called 2-wire? It's simple. Why? Because it's 2 wires. 2 wires go outside for air conditioning. Most of the time, they use white and red. You can buy 2-wire. So don't use your 4-wire, they cost 5 times more, and then not use the other wires. I'll buy 2-wire, I'll buy 4-wire, I'll buy 8-wire for heat pumps. Now, I'm only gonna use 2-wire to go out. all you need. We hook up 2-wire, we hook up the 4-wire at the thermostat, L1 and L2, vacuum the machine, you'll learn that. We'll vacuum it, we will check for leaks, and we will charge it. And we're gonna start cleaning up, cause we're gonna let it run about an hour. We're not running no tests, it's hot and that thing gonna be running. And we're gonna get ready to get out of there. I usually stay about an hour, hour and a half. I get there at 8 o'clock in the morning. Actually, honestly, I could probably have it done at 10:15, but I don't do that no more. Cause people don't like paying all that money and you go, so you gotta have some business psychology. And I stay there and I really make sure everything is neat. I put wire, you know what wire ties are? I put wire ties on them and I cut them. I can't stand to see those things look like snakes. I cut them, clip. Everything I do, clip. Everything is neat. My wire, when I run it in a circuit box, you know how you open up a panel and you see this, wires all over?
Yeah.
Mine go like this.
Oh, okay.
All my stuff is neat. Cause I have pride in what I do. And I warranty and honor any work I do. And if it doesn't work, it's the manufacturer's failure. It's not mine. And you ain't giving me no part. You giving me another unit. Cause it's a limit and I'm not taking it. Not taking it. Take your break. If it doesn't have a load, it's a stick. It's not a power consuming switch. We call it a power passing switch. Because a switch just passes power. It's either closed and you have power, or it's open and it doesn't have power. Now, the component that it gets a little tricky with is, somebody said it, a contactor. Because it's power consuming, but it also passes power when it closes. And so, that's the difference between something being a safety and something being a straight operational type of switch, a contactor switch. But a limit, which we passed around, which is temperature controlled, it's a passing power. It passes power because there's no consumption with it. It might end up on the end where there's consuming, because if we look at series circuit for safety and operation for 24 volts, and we're in the air conditioned mode, what are some of the switches in that line that affect air conditioning? Somebody said it earlier, because we said controls mostly work 98% of the time 3 ways: temperature, pressure, and timing. Whether you have a 7-day programmable thermostat, a day is a time. A time a day is a time. A delay is a time, and that's why we say pressure, temperature, timing. So in air conditioning, we mostly control by temperature and pressure, because we always know pressure plays a part, because pressure is the wall stat. I'm so sorry. Temperature is the wall stat. Yes? This is what we want to get out of this chapter. What is a pass-through device or path device that simply opens and closes is a device that does not open and close with a necessary load, like a contactor or relay has a load in a coil, so that is what has to be energized. And a pressure switch, like we were talking about air conditioning has a low pressure and a high pressure switch, and could also have, like Red said earlier, it could have a condensate switch, but it's just a switch. But here's the interesting part. All series circuits are going back to something, if it's a control circuit for safety or operation. It could be in a control circuit for safety, because in the heating, it's limit heating temperature safeties. In air conditioning, it could be pressure, low pressure, high pressure. High pressure, do you know what high pressure is? Cause they talk about a high pressure switch, but why is it in there?
Maybe because the
If there's
pressure
no
rises.
flow in the system, the pressure builds
To
up.
prevent something from blowing?
Too much pressure.
Too much pressure.
Too much pressure.
What is too much? Pressure and temperature have a relationship. That's a TP chart. If I have high pressure for a particular refrigerant, I also have high temperature. Same for the reverse. If I have low pressure, I have low temperature. So high pressure, that's why we learn components, because it's a safety and it opens. And there are some visually things you can see and know why it's high pressure safety open. For one thing, if that condenser outside is full of dirt, pollen, all kind of stuff, because it's been there 5 years and they never cleaned it, how did we say that we cool off that hot gas that was in this room in order to, not cool off the hot gas, but cool off the temperature in this room by absorbing heat in the evaporator, so that heat goes outside? And if we said if it was 98 degrees outside, 124 degrees Fahrenheit in that refrigerant inside that line, then the air that comes in and on the outside unit, the condenser, it dissipates heat. It gets rid of the heat. The heat it's getting rid of is the heat that's in the refrigerant line that's coming back from the compressor, called discharge gas. It's hot. Discharge means I'm the pipe that's leaving the compressor. Suction comes from the evaporator, which means you have two valves in that compressor. One is different ways if it's that kind of compressor. It's sucking it in, so it's in the suction side. Suction is the bigger line, and it's the line that has the coolest temperature to it.
So that's
But
a
it
low
doesn't
pressure?
have, what's that?
That's a low pressure? The
Low
suction?
pressure on the suction side, but it has a meaning to what that low pressure is. Because low pressure can confuse you on a safety. Low pressure could be perfectly the pressure should be for that particular ambient temperature in that refrigerant, or low pressure could mean I have a leak. Low gas, low pressure, which is my worst service call in the world. I hate it. I hate leaks.
Why?
Because I gotta find it. And it could be difficult. Very time consuming and a time consuming process. And I explain it to customers completely, because it could be expensive. And especially if the service call, this is what you're gonna hear. It's not Freon, what is it called?
Refrigerant.
It's refrigerant. Freon is like Chevrolet, Toyota, Nissan, Ford. It's a name brand. They have Racing, Coolrene, it's a whole lot of different names. But if you have a leak, we should find it, because the service call comes like this. I get a little juice every year. That's what they gonna say. That's what they call refrigerant. Could you give me some Freon? I need a little antifreeze. I know what they talking about. I say, how you know that? I always say, how you know that? Because I get it once or twice a year. You all right with that? Well, couldn't nobody find it. So the leak over time could get what? Bigger. And so I'll put my gauges on. Sometimes it may not be that much, but it'll cool to about 85, and after that, it'll start dragging. And I say, you need to find a leak, because if you have a leak, what are you pulling in the system? Air. Refrigeration cycle does not like air. Air can make pressure in a system rise, because we cannot compress air, we can only compress refrigerant. So I'm mixing your electric with refrigeration, because I always teach higher than where you are. Because it doesn't connect if I don't go higher. It doesn't connect. to talk about a switch and you don't know where it is. So low pressure could say, low pressure could have two purposes. In commercial, we control temperature. How do we control temperature? Because
Okay.
if I control pressure, I can control temperature with a pressure temperature switch. That little screw screws down on the line and we read pressure and we can set that pressure. We can set that pressure and I can control temperature. We use it in refrigeration all the time. Because if I can control the pressure, the dark blue is temperatures. At the top, it's in your book too. I think it's on page 63. Oh.
In the big one?
It's okay. I got.
What is that going to right there, that,
What?
right there? Where-
That wire?
I'm saying, where do that part go to?
It goes to, the low side, if it's the low side, component. And that's what you're gonna learn, that it goes to the low side of the system, and that means that it monitors temperature, how low it gets. We set it. It's a control. It's a pressure temperature control. For instance, if I said at the top of that chart, which it is in your book though, it'll be a chart in here. This is a newer book, so it wasn't on the one that I had. There goes one.
You said it's on 62?
No.
I thought it was, but that's in the old book. It's in that chapter.
Temperature,
It's on
pressure chart.
it's on 2 pages in the, it has 2 different pages.
It's, appendix B, 1612.
We went over that already.
Way in the back of the big book, y'all, 1612. And 1613.
Man, that's at the back of the words. They done changed the book.
I think that book was first though.
Same size, they redo it every 2 years.
No money.
And that's one, temperature conversion chart. Temperature conversion, so they going, that's the temperature conversion, but this one on the other side is temperature to be converted. Okay, so if I have, well, that's not the chart, because that's dealing with Celsius. And I want the one just like that with temperature and pressure. And I know it's in the early chapters, because we always use it. Because that's a baby one right there. So I know it's right here, because they're talking about it there.
Oh, it was on small book, wasn't it?
Huh?
I thought we started from small book.
It's in this. But this is talking about charging, so it should be right here. Because you're talking about charging refrigerant in chapter in unit 10. And I keep seeing little baby ones right there.
267.
Huh?
267.
Well, how come I didn't see it? I'm in that section. Three?
267.
For this chart, it's not that one.
Cause they got some little ones in here. They
Page
talk about that.
47.
Anyway,
It ain't
okay,
this right here?
what? That's it.
Yeah.
What page is
Okay.
it?
Page 46.
I know we went over together.
I'm like, man,
No, yeah, 40,
It's on page 46 right now.
43.
He found it.
He found it.
This
This time.
okay, so the different colors represent what?
Different refrigerant.
Different refrigerants. So most of the time, you're gonna be using 410A, what color is it? Look at the top. What color?
Pink.
I like to say it's
Rose.
rose.
Okay, Rose.
But that's what it is. Okay, so here's the deal. If I say, the way you read it is, if we were to put all the temperatures in a row, it would be from the ceiling and the floor. So they make 3 panels, so you can still continue with the
Right.
temperatures. Okay, so if we say 410A at 80 degrees, what would it be?
What's the 235.1?
At 80 degrees,
235.4.
okay? So that means if I have a temperature of 80, the temperature is gonna be 235 in pressure. The pressure is gonna be 205. So 80 degrees temperature, and you'll learn how to read the gauge, it will be 235, which means that refrigerant boils at 235, it changes state. So if you have 40 degrees, what would it be?
40 degrees,
18.3. So if it's a 40-degree evaporator, that refrigerant is gonna change its state, that's what boil means, and that pressure is gonna equal 118.
You said, instead of saying boil, you say it changes state.
What's that?
Instead of
Well, yeah,
saying it
boiling
boil.
means changing state. Condensing means the state is changing from vapor to a liquid, that's on the condenser. On the evaporator side, the liquid changes into a vapor and it boils off. It's not boiling like you boil hot dogs. It just means it changes states of what it is as a liquid to a vapor, and it becomes a vapor. And we speak in terms of our business as liquid and vapor in air conditioning.
And then what blows out?
The vapor does not blow out. The temperature is inside the line
Oh, the
set.
temperature taking the heat.
And so the temperature doesn't take the heat. Remember, I'm teaching you how to say this. We said that it absorbs. It absorbs because, and we're gonna say this forever, that heat goes from warm to
Cooler.
what is warm? This room. If we had air conditioning, what would be the coldest point of the air conditioner? The evaporator. So the evaporator is gonna absorb. As the evaporator absorbs heat, how does it maintain 40 degrees? Seems like to me, if it would absorb heat, then it would get hotter and hotter and hotter and hotter. How does it maintain 40 degrees?
Pressure,
Is it burning out?
that's pressure and temperature relations, proper
Refrigerant?
temperature switch.
Yeah, refrigerant.
The
It
refrigerant.
doesn't allow over a certain
I would
amount.
think it's refrigerant.
Keep the temperature and
How?
pressure relation.
Remember, we're talking about components.
Oh,
Thermostat just says run, baby, run. Thermostats are very obedient. And let me tell you something about machines, because I look at machines like they come alive in my mind. I'm really connected with machines, and machines are very obedient. How do we make them stay obedient to operate how we want to? By controls. Controls make them come on and off. That's how they stay obedient.
So it goes to a pressure switch? Is that what you said, how does it?
Not a
stay?
pressure
It goes to
switch,
a-
but you're on the right case. It's not a pressure switch,
But
but it is a TXV, is one type, a metering device, which most of the time, but I talk about more than this, because that's all they ever tell students is TXVs and thermal expansion valves, and it's more than that, because if you look in this section of metering devices, you're gonna see a bunch. So the metering device, let me do it this way, so
Like
that,
an orifice?
it is an orifice. It is.
But the evaporator, how does it stay? So
I'm gonna tell you how.
so the thermocouple's like a TXV.
Then they just change the pressure.
Thermocouple is a TXV.
Turn the pressure.
It's a thermal expansion valve. So here's the way it goes. Really what it is, he said it right, it is a restrictor. Like your water hose, I can have it wide open and it'll go to there. But buddy, if I crank it down, I'm gonna hit the wall, cause I restrict it and it increases flow. And it changes the pressure and it goes for it. So, restrictors are also metering devices, and I'm gonna show you how that works.
This changes the pressure.
And
Pressure washer.
sometimes we refer to them as MDs, because we get tired of saying mid-air device, so our business always cutting something short. We get tired of saying evaporator, what do we call it?
Evac.
A evac. Get tired of saying it. Okay, so it could be a TXV, which equals a thermal expansion valve. Thermal expansion valve. And it could be a TEV, which this one has always amazed me, because I don't understand why they say TXV and TEV, because TEV is a thermal expansion valve. I just accept it. And then, same. And then there is a, EAV, which is a electronic expansion valve. Then there is a AEV, which is a automatic expansion valve. Then there is a piston, you heard of that? Which is a fixed metering device. Has no moving parts per se. Fixed metering device. Then there is a capillary, referred to as a cap tube, which is a fixed metering device, which means, again, we'll be going on this stuff so much. Don't get blown away. Pistons, actually, they don't pump like a piston in a compressor. A piston is inserted in a line set that creates tension. This could be at the evaporator.
What is this again?
Piston could be here, and a piston
What is this?
looks like
No, I need to know what it is. Hey, classmates, what is this? Huh? What is this?
piston looks like this, and a refrigerant goes through it. And sometimes a piston works on
Some kind of pressure switch.
condenser temperature.
Name of this device again, please?
That is a pressure control. That is a,
High pressure switch.
No.
that is a adjustable pressure control. I can adjust the temperature. The ones that we're talking about that's on air conditioning lines for residential, it will be a thermistor. And it has 2 wires. And it
This
connects
is,
onto a liquid line,
Dryer.
and it reads pressure. We
Liquid
have,
line,
the
filter
vapor
dryer.
line, the big one, it reads pressure. They are manufactured to read pressure from the high side or the low side. They're not adjustable. They're made for residential, which means that if it gets to a certain low pressure, the switch will open. If it gets to a certain high pressure, the switch will open. It will open. And there's safety switches to let us know. Some older units never had them. Machines are obedient and machines don't know. If you don't have a pressure switch and you jump it out because it needs to be changed, what would a machine do if you get high or low pressure? It'll continue to run until it tears up. So what does that mean for low pressure? If you have a leak, it will run till the compressor dies. That's why you have to have pressure, is to save the most expensive component. That's what safeties do. They save the most expensive component. And I always go back and forth like this because we talk about a pressure switch, you need to know. We said we want to know what it does, we know what it looks like, how does it operate. If it's a thermistor, it usually tells me that it's tied into the control circuit as well. On some units, thermistors are usually tied into a board to take instructions, and something happens because all either meter devices, thermistors, the TXVs are measuring devices. They're measuring devices. And if I measure something, I want an action. So they're measuring. So when we look at a TXV is gonna be, and I'll give you a paper on it, because I'm big on TXVs. I'll tell you what all this means when we do that. It has a sensing tube. Because I'm gonna answer your question. And you say, well, how do we maintain 40 degrees? So the sensing tube, the metering device is put into the 3/8 inch line, which is a small line. So the liquid, this is something you need to know too, is that the liquid is flowing through that small 3/8 inch line. But that's how the refrigerant flows. You're gonna get it, it's gonna come. It's coming from the condenser. That's that high pressure, low pressure.
I can't see.
Okay. The superheated refrigerant. And so it's attached. That's how you make a pipe look open. It's with the number 8. It's attached to the suction line that's going into the compressor. It's attached to that. So guess what? That's anytime we have a sensor, it's measuring. How do we keep 40 degrees on the evaporator? We measure the temperature of the refrigerant leaving, right? So if the temperature entering is, I lost my evaporator.
It's right there,
Here,
yes.
is 40 degrees Fahrenheit. If it's leaving, coming in and it's 40, 45, and it's leaving at 65 or 80, that's not good if it maintains that, is it? So this sensor, this is so cool, this sensor says, hey, it doesn't say nothing. It senses and gives a measurement of 80 degrees and says, it doesn't say that, Harrison. It causes for an action because it doesn't talk. It causes for an action of the spring and the baffle to say, hey, it's a pressure operated control. And we control the temperature of the evaporator by the pressure that's on this line. Isn't that cool though? The pressure, like the chart, controls the temperature. How does it do that? Okay, so this refrigerant coming back from the condenser is gonna be a 100% liquid. As it goes through here, it's restricted and it lowers the temperature. So when it goes in, it's gonna be a low temperature liquid and it's going into, this is the liquid line here, but this that it's attached to is attached to the evaporator. So as the spring tension says it's 70 or 80 degrees, it starts to open and let more refrigerant flow. So as that cold refrigerant comes, that liquid refrigerant, it maintains 40 degrees evaporator temperature. So if I can't make, well, I don't care about all that. I just want to put it together and give me some money. Okay? You only gonna get a certain kind of money then, because you gotta know these parts and what they do. So if I know that I'm not getting enough temperature to maintain 40 degrees, it tells me where to look. Either I'm low on refrigerant, right?
Yes.
Either I have a clogged TXV, I have a clogged, restricted filter dryer, something in that circuit is going on that I cannot maintain temperature on that evaporator. It tells us how it works. You're not gonna get this in one day. I'm just trying to tie it in so you'll be more serious when we talk about components. Yes.
But in the chapter, it says that even if the switch is open, sometimes it still can read the same voltage. Why?
If a switch is open,
In 15, it says,
if a switch is open,
sometimes it still can read the 230 voltage.
If that motor,
if it's open, it reads back EMF. If the switch is open, it reads potential voltage. If it's open, it's gonna read the voltage that's there. gonna read no 230 off no one line, though, I tell you that. What's it gonna read? 115, 120, you know how it does. It's gonna read one, and that's a good question because it's all on third semester. Core has like 15 questions like that,
Like what?
like what you just said.
Okay.
So in other words, it's gonna say, if we, really here, if we have a switch that is open and it's on a 120 volt line, and I take my meter and go from one side of the switch to the other side of the switch, what will I read on my meter?
0, 120.
On an open switch with 120 volts applied. It's a very difficult concept for new students to understand. It seems like it should be 0, doesn't it?
Where are your meter points?
L1 coming in.
But the service is open.
Where exactly are your meter points?
You can't have 120.
It's 0.
It's 0. It's potential. It's potential. BMF. I hate saying that because it sounds nasty, don't it?
No, it don't.
Back motor force. Back motor force. Back motor force. Potential power. Here's what it means. Potential voltage if it were closed. That's not what you would read, but that would be the voltage. So seeing that this is very difficult to learn when you start learning electrical. Because a switch open and a switch closed, that would read 120 volts because the switch is open for back motor force. That's what that is. If the switch was closed and you put your meter on the same wire, what would you read?
0.
0, because there's no opposition to the flow. I can't read something unless I have a positive and negative, or resistance, but we
That's
never
what it
read.
says in it says exactly that. You would be testing. It's on page 368. It says, there will be times when the technician must switch the meter to on and shut the electrical power off in order to solve the problem. And they're talking about the motor. Then it goes to say, down a little bit, hold on. RNC, if they run winding between RC open, causing the motor to stall and draw lock rotor amperage. That's what that is. That's what you're teaching us.
Lock rotor.
Okay. This, of course, before the overload has opened. Notice that a multimeter placed across the RNC terminals of the motor, the open winding will again read 230 volts. That's why I asked you.
It's reading that because it is that voltage there, and it's still reading an open switch. It's reading an open switch. It's reading an open switch, let me see. Trying to take this and switch a meter to ohms. The meter to ohms. And shut the electrical power off. Shut the electrical power off in order to solve a problem. What would be the voltage from R to C? If the run winding between R and C are open. Here's R to C.
You should be in the picture.
24, 5 minutes. Should be the diagram next to it, too. Okay.
R to C. Oh, that's a different one. Is the power off? It would be reading no voltage if the
That's
power
right.
was off.
Yeah, that's you.
How you gonna read voltage if the power's off? If you're using,
Potential.
oh, I know, I probably was reading, I was looking at this one and they're going across the windings. If the winding is open, I would be reading a winding from ohms, so you were talking about voltage though. If it was powered up and it failed, well, it couldn't be short because it would kick out. So something had to be open.
If it's
It
still
could have been
getting
an
voltage,
internal
right?
overload, let me see.
Yeah, that's what it was.
Oh, because if the internal overload is open, then you don't get that voltage going across. Because the internal overload means you drew too many amps, and it saves the compressor. An internal overload is a temperature safeguard switch for the compressor windings not to burn up. It opens. It's opening. It will reset when the temperature goes down, and that's one of the things you have to be very mindful when you first start doing HVAC, not to take a resistance reading off of these terminals and say, open line. It might not be the compressor. It might be the internal overload. Now you done bought another compressor. The one you had was good. Maybe it opened because the condenser was dirty. Maybe it opened because the condenser fan motor was not operating. Maybe it opened because it had a restriction. Maybe it opened and drew high amperage. Maybe it opened because the line was crimped. I've had lines people step on, and it draws high pressure. It was brand new, and I put it in the day before, so I was hating it. And I did it for a lawyer, because I have a lot of high end, so you know I gotta go. And he was all nice. Mr. Harrison? Yes, sir. Well, I think I'm having a little problem with my unit. It was working fine yesterday, all weekend, and now today it's very hot. Think you could come by? I said, be there an hour. And so I get there, there's little grandkids out there. Little black kid, about 4, and he was talking to me. I was like, what language is he talking in? And he was serious talking this language. I said, it doesn't sound like no language I heard. And he was speaking Israeli. I said, how your grandson learn how to speak that language? He said he lived in Israel for 7 years because his father played basketball over there. He said he could speak English. And he could speak other languages. He said he's messing with you. He's 5 years old. He said he's messing with you. He said, stop treating Mr. Harrison like that. He started speaking English. I was like, man, I'm getting too old for this stuff. And so I look at him, and he has these little toy soldiers, right? Oh, he was having a good time. They was climbing all over the condenser. He said, Mr. Harrison. I said, what, buddy? He said, I'm having a war over here. I said, what you having a war for? Because people have wars. I said, okay, that's probably why they do. And I said, so who's winning? He said, I'm winning, of course. I said, how do you know you're winning? That's a little boy. He said, because I have more soldiers and I have more tanks. And I said, so how can you tell? And he lifted up this brick and he said, I dropped a bomb on that water line. And I looked, the Freon line, the refrigerant line was flat as paper. And I said, oh, I know what's wrong with it now. He flattened the heck out of it. And so I turned it off, and I told his grandfather, I said, sir, I found out what was wrong. He said, what? I said, your grandson was in the war, and dropped a couple of bombs over there. That's his explanation. And that's the result of the damage from the bomb that dropped. And he looked, oh, it sure is. He said, what can you do about that, Mr. Harrison? I said, I can try to change the line, because I don't know how long it ran like that, because it was pumping down. But the only thing that saved it, a pump down, that means when all the refrigerant is restricted from going to the evaporator, it comes back to the condenser. So I can't figure out. I said, well, maybe that internal overload shut it off and saved it. And then when it cooled off, it kept coming back on. I said, I'll cut the lines, take the refrigerant out, and see if we can crank it back up. And I said, okay, and it worked. But I said, you know, it could have did some damage. We might end up replacing it, but it's working now. He said, we'll deal with that later. He said he's gonna make a great general one day. And I was thinking, that wouldn't have been my household. I'd have been taken captive. That would not have happened. And I did another one. That was another lawyer. And he said, Mr. Harrison, it's not working. I'm like, what's the deal? I was, you know, what's the deal with all this not working? I said, I'll be over there. So I go over there, and I look at it. I put my gauges on, 0 pressure. So what took it out? If it's 0 pressure, what switch open?
Say,
What switch made it open?
pressure.
Low pressure.
Oh.
Cause it had no pressure.
Oh, okay.
No pressure worse than low pressure. Cause what that mean, if you look at your gauge, it got 0. I said, oh man, they got a big leak. I don't even wanna deal with it. It's nasty. So I keep looking at it, you'll learn, put some nitrogen in it, cause nitrogen you can let run out. It doesn't do no damage to EPA, ozone or nothing. And I heard it hissing. And so I hear it hissing, I look at it closely, it's brand new, like a day old, and I see brass in it. I'm like, what's that, copper? And I keep looking, it was little balls. And I said, those are BBs. And I look and I pick one out, I said, how I get BBs in the unit? So I told him, I said, I found some BBs, you got like 10 of them in here. And he says, I know where it came from. And I said, well, I thought he wanted me to pay for the unit. I said, where did it come from? He said, the little boy over there is 10. His father bought him a pellet rifle. And he was in the prime position shooting at paper targets. What happens to a paper target? It went through it, and he filled up his new evaporator with it. And he said, can you fix it? No, you have to replace it. He said, replace it today. His father will pay for it. So those are service calls you don't know, but it was low pressure, no pressure on those. So I want us to get used to wiring and understand fully what a powered on open switch is. Again, what reading on volts?
Open.
120.
Powered off.
Whatever.
A powered up
Open switch, 120.
open switch with 120 reads what across the
120.
meter?
120.
It reads 120. If it had 240, what would it read?
240.
Whatever that is on the open switch, that's the voltage it's gonna read through your meter. And also, if it was closed, you would read
0.
Now, that's the way that Nate does it and a lot of other ones, but have you ever heard in this electrical yet, long arm? How you test long arm? Some people do long arm because it's easier. I do long arm because it's easier. So I take one of my meter ends and I put it to ground. It could be case ground. I take the other point of my meter, say this end, this one is on ground, this end, that's the switch. Where's my other wire to my meter? This one goes, this end goes to ground, and this end, because that's the other end of the wire, this end goes to this wire. What would I read? With one side to ground and the other side to a hot side, what would I read?
120.
120. It's called long arm. It's real safe because it's easy. If I take this end and put it here on an open, here on an open switch, what would I read?
0.
0. It's so easy. That's why a lot of people do it. It's real easy. For people that don't want to deal with an open switch, reads voltage of anticipated voltage, and if it's closed, you'll reach 0. Because a lot of times when you're new in the field, you should check yourself long arm, because you could replace components that have not failed, because you're not understanding that 0 doesn't mean 0. Because if you touch it, you'll know it doesn't mean 0. So that's one part that I wanted to really get that into your thinking process of troubleshooting. What the component looks like, how does it function, and we're gonna have quizzes on this. How does the component function mechanically and electrically? Is the component a load component? Is the component a pass-through switch component? Is the component some of them are twins, where they are a load and a switch. A load and a switch, like a contactor would be. A load, when it closes, is a switch. And that helps us understand how to service a piece of equipment. So if the contactor closes, what do you know?
It's a load.
It's a load, but what do you know about that device?
It's running.
That it had 24 volts. Hopefully, it had 24 volts.
Oh, yeah, they had one, okay.
Because it closed.
Yeah.
But it's not running. What does that tell us? This is how you think when you service. If I have 24 volts and it's not running, where you gonna put your meter? We talked about it earlier. Where you gonna put your meter right off the bat? L1, L2. I can do it from the disconnect, or I can open up and do it from the contactor. Because the contactor has L1 and L2 that come from the disconnect. If I go to the machine outdoors, go across that contactor, L1 and L2, and have no voltage, what does that tell me? No voltage at L1 and L2 at the compressor contactor.
There's no.
You never see it.
The line
Oh,
that's
true.
coming in. The line that's coming in is low.
L1, L2 ain't got no power.
That means you're
So
not
how
getting-
could I test if one of them has it or none of them have it?
You gotta put power to
Ground.
L1 and power
A ground
to ground.
and go to L1. If I have 0, there's no voltage. If I go to L2 and it's 0, it has no voltage, where am I going now? Where? The service, I'm going back to the breaker. Because the service disconnect gets its voltage from the breaker. Do you see how that works? And that's how we trouble. I don't need to look at no machine. If L1, L2 don't have anything, and I hear click, that means what is working? The low voltage is calling. We say that's calling. It's calling for cooling, but nothing is running because L1 and L2 don't have anything. So if L1 and L2 don't have anything, T1 and T2 don't have anything, and nothing runs. So I'm going right to the breaker. I'm going to the breaker. And if L1 and L2 don't have any voltage, then what happened to the power line? What happened to that voltage that's coming there? So we can tell by looking at the breaker, and what color would it be if it had tripped? What color is this breaker when it trips? It should be red. Red. That means it tripped. If it's all the way over, somebody probably turned it off because it's not going all the way. You have to turn it. So you can try to reset and then on, and especially after a storm, because like my house, the power said blink, blink, and then breakers go off. Why did them breakers go off? And the unit was running and came back on again. Why did it go off? Because it drew what?
So much amps.
Which is called
Surge.
LRA. Lock roll L. It drew it off. Because it drew that much on the start. Whole neighborhood is starting the same way. It could take out the power coming to the neighborhood. Or if lightning hits that, it's gonna take all the power out. Boom. Car hit it, boom. Power gonna be out about 6 times. Did you know that power will try to restart? Do you ever notice when power goes off, it'll blink off? And then it'll come back on, you're like, yay, then it go off again. And then it come back on, you're like, okay, and then it go off again. That's design. What is that designed for? It's automatic. At the power stations, they will reset 3 times, automatic. If it doesn't, if the lights don't stay on after the 3rd time, they're not coming back on. You might as well take your cell phone out of the car. Greystone, Georgia Power, Peachtree, whoever you have power with, you better call them. And when you call, they already know, because they have electronics on their end that shows up through automation what's out. They see it, and that's why you're gonna get a message. We are experiencing power outages in your area. We will be dispensing the service crew as soon as the weather breaks. We anticipate, and it's 9 in the morning, it'll be complete by 6 p.m. Cause they can't work in the rain.
It'll be like 4 days.
What time is it?
Well,
Like, we don't see in about 4 days.
12:20.
Tell me something else about 15.
But I skipped number 17, it was asking why you use a multimeter instead of a voltmeter.
A multimeter instead of what?
Voltmeter instead of a voltmeter.
You can use a voltmeter if you want
Give
to.
you this on page,
That's a multi because what? You can do voltage, amps, microfarads, resistance, that's multi.
because you tested for resistance on that.
When the
I have a
device is
voltage
on.
meter, we call them, high def. You know how you name stuff. All it does is voltage.